What's up?
Hi, Joe.
Hello. So we're hanging out at the Forward Data Conference in wonderful Paris. So good to finally hang out.
Yeah, Joe, it's amazing. I didn't think that we had to come to Paris to finally meet. And I was expecting somewhere in the US, but hey, here we are.
Well, I was actually in your neck of the woods last week in Amsterdam, but we didn't.
Yeah, somehow managed to miss each other, but
I forgot to send the fax.
Yeah.
So.
Oh God, the fax machines. Yeah, this is a something embarrassing for the people of Germany to still using fax machines.
They still use them?
Yeah.
For what?
I think if you want to talk to some official thing like a government agency, they like faxes still. Although I have recently read that I think the tax people are now stopping to accept faxes finally.
Oh?
Yeah, I know.
Coming along.
I know. It's almost that digital technology could be used for this purpose. I don't know.
It'll make sense when they're older.
Yeah, no, it's really a pleasure to meet you finally. Obviously I have a copy of your book.
Oh, you do? I didn't know that.
I do. I use it in my class, actually. I teach a course called Data Engineering.
Oh.
Yeah.
Well.
And the university was like, is there a textbuck? And I was like, yes, there is one.
No way, I didn't know that. That's so cool.
Let's use that one.
Well, if you ever need a guest lecturer, I'm happy to pop by on. If I happen to be in the area, I can pop by. If not, we'll do it over Zoom.
Oh, that would be interesting, actually. Yeah. Thanks for that. Yeah.
Yeah, it'd be dope.
The students will be thrilled. Yes.
Yeah, well, or dismayed. They'll drop the class.
They don't obviously believe me when I say something about data engineering, but they will believe you.
That's cool. I guess to kick things off, for people who don't know who you are, do you want to give a quick intro?
Sure. So my name is Muhleisen. I'm from Germany, but I live in the Netherlands. I have been living there for 12 years. I am one of the two creators of the database system called DuckDB, and I'm also the co-founder and CEO of DuckDB Labs, the company that employs most of the DuckDB contributors. I'm also a professor of data engineering at the wonderful university in Nijmegen, which is a small town.
That's super cool.
Yeah.
DuckDB, I could make a very strong argument. It's getting up there with being a very widely used database. I think in terms of mindshare, at least in the analytics community, I would say it's probably the hottest database in the world right now, in my view.
I think that's true. Like we do track a bunch of these vanity metrics. Not too seriously because
what's a what would you
there's
look at?
like things like the DB engines ranking, and there is things like amount of downloads. But I like the metrics that are sort of not gamed by scripts, right? Because DuckDB, of course, and I should maybe explain is database as a library, right? Data warehouse as a library, if you want, and that means that people run it in all sorts of creative places, and it very often gets installed just to spin up a Lambda or something like that. So that, of course, that would skew your download numbers. But there's metrics that are not that skewed. One of them I'm really impressed by is the amount of unique visitors to our website.
Okay.
So we accidentally made one of the more popular websites of our country.
Really?
By just having our documentation and our blog and all sorts of things like that. With more than 1 million unique visitors each month for just the website. Yeah,
Dang.
It's totally wild. I don't know. I didn't expect that.
How many downloads have you had so far?
Downloads, that depends a bit on the platform. So there's Python. They have a big Python distribution.
So like in PyPy? Or?
Yeah,
okay.
It's on PyPy, and it's I think 7 million per month at the moment.
Okay.
I actually have no idea what the integral of all of this is.
Okay.
There's a sum in that sense. There we have that. There's a bunch of other platforms that get downloads. But Python, I think, is the biggest. NPM also has a bunch. On our client, there is direct downloads from a website of the CLI. There's things like Homebrew, which goes through them, and we can't necessarily track it. So we don't actually have a great way of tracking downloads. But what we do have is these extensions, plugins, and those go through our download server, and that's currently on the order of, I think, 300 terabytes each month, just in extension downloads. So that's just somebody installing a DuckDB extension, and that sums up to 300 terabytes. By the way, grateful to Cloudflare for sponsoring us.
Shout out to Cloudflare.
Yes, thank you. That would be, it's not that Cloudflare charges you money, but it's something that gives us like the confidence that we can pull this off for the next 10 years
to
come. Yeah, it's quite wild. it's somebody, Jordan has said at some point that if what you're doing is exponentially growing, every day is the craziest day of your life. And it has definitely been how
is
it
that Jordan?
feels. Jordan Chigani,
okay.
Of Motherduck, yeah.
Okay, I'm sure like Michael Jordan. Or...
No, that's the other. Yeah. So that's really something that has surprised us. Obviously, if you make an open source project, your default is that nobody will care, right? That's true for 99.9% of GitHub repos. Nobody cares about them.
Yep.
And when we started building DuckDB, obviously we thought we had a bit of an angle on what could prove to be popular, but obviously you have no idea without it happening, right? So you don't know. It's still unlikely to happen. So it was an interesting experience. I think it's interesting if you wonder. I think we knew that we were onto something when the VC started calling.
Oh, right. Tell me more.
Well, okay. So DuckDB we've open sourced it in summer of 2019.
Yeah.
And then we spun off the company in about 21. But before that, actually, in early 21, I think, there was, I think, a Hacker News post, which was a terrible It was a terrible article. It was like, here's DuckDB. It's like Postgres. That was, I think, that I remember.
Who wrote it?
I don't remember who wrote it. Not us. Okay. It's like SQLite. I remember. It was, here's DuckDB. It's a database that's like SQLite, but with Postgres features, which is a very bad characterization of what DuckDB is. But that went viral on Hacker News. And that was that I think was what pushed us over the 1,000 stars in GitHub or something like that. And that was when, the curve started to take its current form. We're now at something in the order of 25,000 stars in GitHub or something.
That's
like
a
that,
lot.
Which is not a lot if you have a JavaScript library.
True.
But for a data system, it's pretty crazy. Yeah. It's been a wild ride. I have to say.
That's interesting. Walk me through the beginnings then. So, and actually we were talking about it earlier. So, walk me through the database. Walk me through how you named it. All those kind of fun things. I think it's pretty hilarious.
I mean, the database name, to be brief, is called DuckDB because I used to have a pet duck. So I live on a boat with my family, and the neighbor's cats kept drowning, and so we decided to not have a cat.
Sad.
Because they fall in the water. It's really sad. So we thought we'll have a cat. We'll have a duck instead. I'll have a duck instead of a cat, and the duck can swim. So we got this little duckling called Wilbur. I taught him how to swim. I taught him how to fly. It was very sweet. And he has since left and probably has started a ducky family somewhere. But in honor of little Wilbur, the database is called DuckDB. I don't know. It was kind of obvious to me. I didn't have to think about it a whole lot, but
that's hilarious.
But yeah, that was very early on. And DuckDB is a product of Mark Rasfeld and me originally. And Mark used to be my PhD student because I come from this whole academic background from back in Amsterdam at the Centrum Wiskunde Informatica, which is like their national research lab for mathematics and computer science. It's by the way where Python was invented.
Oh, really?
Yeah, they invented Python. Guido invented Python while he was there.
Wow.
In the same sort of research institute, we came up with this idea for DuckDB because we realized that people kind of were sort of ignoring database technology for the wrong reasons.
What do you mean?
Well, so obviously databases is this like relational data transformation is something that is well understood, I would argue. It is also a field with a long tradition and a significant body of work and best practices. But people were casting that aside for reasons like, oh yeah, but it's super hard to get Postgres running. I'd rather run like MongoDB, which is vastly inferior from a technical perspective, but it was easy to get running. Mm-hmm. So we took some inspiration from that and actually said, but what if we take the sort of the body of knowledge, the orthodoxy of what the database engine should look like, and just put it into a package that doesn't make you, hate everything and everyone around you. I tried to install Oracle on a box, and at some point I realized that normally consultants do this.
Yeah.
Because it is horrifying, right? And so with DuckDB, we really try to be like absolutely like minimalistic in terms of what you need to install it. There's no dependencies, right? Zero. You don't need root to install it. It's small-ish. It's like tens of megabytes of binary size. It's just generally trying to be not unobtrusive, but still contain a state-of-the-art query engine. And we've actually since we've done that, we actually went much further. So we're still doing research in the field of databases on how we can, make DuckDB better. Like we're doing research, for example, we just wrote a paper on parsing. We did a bunch of papers on bigger than memory processing, which is something that surprisingly not a lot of work had been done in the field.
That's interesting.
So we are still, actually, let's say, pushing the envelope of what a relational engine can be, but at the same time, we're making it trivial to use. And I think that's the sort of interesting sort of combo.
Yeah. Well, and we were talking last night too. You even have somebody working on like the CSV.
Yeah.
Parsing.
Yeah. So shout out to Pedro. Who's one of the, I think the second or the third, first or the second sort of person besides Mark and me to work on DuckDB. He was a postdoc at the CWI, and he did a bunch of stuff. He did like the art, like a tree structure for indexing. But then he found his true calling, which is a CSV reader. And so he's been
noble calling.
I know. He's been working on the CSV reader ever since, and other things. But it's like his main project, and it's super interesting to see, what he's done. And I think the reason why we're spending so much sort of time on CSV reading is because it is the first thing you do.
Yeah.
You're running a new database. First thing you do is you're not going to enter your data like with the keyboard or anything like that. You're not running insert statements. You're going to load some CSV files. These days, ideally, it's going to be Parquet files, but it's still going to be CSV files. And so I've spent so much time of my life dealing with broken CSV readers out there, and that it's absolutely clear to us that this needs to be absolutely top-notch. We need to have the best CSV reader in the business, and I think we actually do. So that's just to keep this initial threshold of people using your system somewhat manageable. Like they need to be like, I think our goal is people like point this thing at something. Can be a CSV file, can be a Parquet file, can be a bunch of JSON files. Last week I worked on Avro files. Anything, point it at it, and it will just be like, yes, sir, here's your table, right?
Yeah.
That's where we want to be. I think we're pretty close. So that's, and I think it comes back to this idea of like user experience. I think databases, I always say they tend to be sold on golf courses because like the CEO talks to the other CEO and they go and then they agree on a price, shake hands, and then that's how the database was sold. We don't do this obviously because it's free and open source, but we have a more bottom-up strategy, and to do that, the experience needs to be good, right? People need to we try to amaze people a bit with, okay, this can do this and it works fine. And people seem to like it, what can I say?
That's interesting. So do you have like an opinion on guardrails as well, or is it more is your philosophy just make everything as simple as possible no matter what it is, or do you have certain opinions about where those limitations should be?
What do you mean by guardrails?
Guardrails, like we were talking last night about strings. I think you're giving an example there where if you want to do something with a string, go for it. We don't really care.
Oh yeah. That's interesting. I think that that is about the schema. Well, you have obviously been working on schema stuff, so we've been talking about that. But let's say to be more forgiving, I think databases traditionally have not been very forgiving. We try to be forgiving in DuckDB, more so maybe than other systems. So we have things like we have like this intermediate compression step where during execution of a pipeline, we will actually look at the types and the statistics of the types that are in the columns in the data, and then we will actually insert intermediate compression, decompression steps just to lower the memory pressure on the way and the complexity of operations. So it will actually not make a huge difference whether your type is declared as let's say a string, but only contains integers between 1 and 100. You will still get a good sort of result in terms of performance. Same for storing things, right? We have a bunch of optimizations for storing very short strings for storing very regular strings. We have we have integer compression. We have there's a lot of sort of stuff that happens magically behind the scenes, so you don't have to think about it. Like our on-disk compression representation, like if you can use DuckDB to store a database file on disk, and there is this. You can say which compression you want, but by default we will actually run sort of an explorator sort of exploration of like, okay, let's try all our compression mechanisms. Which one is working best? Okay, this one, great. Let's use this one. We also have things like, if you have an expression, let's say I have a let's have select star from table where, I don't know, length of where this regex matches, and this other value is bigger than 4. Okay. Now, just if you visualize this, I have a filter that says if the regex matches and the other number is bigger than 4, then the role should qualify. Okay, so now for maybe not everyone knows, but matching a regex is way more expensive than running a bigger than 4 comparison. So we actually automatically will reorder this comparison. So we first check the 4 comparison and then check the regex, just because we need to we want to be forgiving in terms of performance. We also don't want to create these crazy performance cliffs that people generally hate databases for, right? Where you change one little thing, you add one value to your rows, and suddenly, boof, the plan changes and it's over, right? Like we want to be a bit more robust there. Not saying we're entirely there yet, but it's definitely a goal. It's just, I think, it's just trying to be friendly. I think it's the general goal.
If I want to be more strict, do I have that option of making it?
It's interesting that you say that, because we get the request every now and then. If you want to be more strict, I don't think I can mention the compression technique. You can force a specific one. I don't think you can force a specific execution order for expressions. I think we will always optimize it. But it is definitely something that, as people productize DuckDB more or put it more into products or tools that do something else, but they also include DuckDB, that we probably will we will not get around having flags to make them more more deterministic, just because you don't want it to change its mind 3 years down the road, right? Like that's exactly the danger that you can have there.
Absolutely. Well, especially if you're doing using DuckDB on the edge, for example, and you can't update it as much, then
there's people that are running DuckDB on all sorts of devices. And it's something that in the past I think that wasn't a very good idea. Since we released 1.0 this year, I think we are comfortable with the idea of somebody running that version of DuckDB somewhere for 5 years and it working out fine. We do regularly test against regressions against DuckDB 1.0, and so far we haven't found anything dramatic. So that's good.
Funny. Where's the craziest place you've seen DuckDB deployed?
So one thing that's really crazy when I saw it first was the web browser.
Okay.
So Andre Cohn from the Technical University of Munich, he made DuckDB Wasm, which is this version of DuckDB that's compiled to run in WebAssembly in the web browser or somewhere else. I think when I saw that, I was deeply impressed, because I didn't even consider that to be a possibility, that you could run DuckDB in a website, and you can, and lots of people use it. It's one of our biggest sort of deployment targets right now, because people use it. Yeah, people put it in dashboards. People put it in, people use it in like something behind the scenes on a website. Like we have people in visualization that use DuckDB Wasm to just drive a visualization, to be reactive to user input live, like right there on the thing. That I think was the craziest deployment target. There's of course always the random weirdos. We have valued contributors. we have somebody that managed to compile DuckDB for the IBM mainframes, like IBM Z series, which I didn't think was possible, but it worked, and he's happy, I think. So that's always funny. There's
what would that be used for?
I mean, that's not such a terrible idea. I mean, DuckDB is going to be working, I think, pretty well on this. Like, okay, maybe not on 10,000 cores at the same time, but if these mainframes, of course, allow you to use fewer cores for a problem. So you're running there, good memory access. I don't know. I've never used one of these things. I'm sorry. We don't have enough money for for IBM Z series in the
Someday,
basement.
VC, send him some money so we can get an IBM mainframe.
We haven't taken any CVC money, so regrettably, our cocaine budget is limited.
Dang it! Well, you're in Amsterdam. I guess that's the change.
It's difficult.
IBM mainframes, Coke, whatever.
Boats. I don't know.
You have a lot of those in Amsterdam, though.
Yeah, that's true.
That's interesting.
Yeah. But it's a fun ride, I have to say.
I think you said that there's space satellites running DuckDB?
We haven't gotten confirmation. We just went through the official software procurement process with NASA recently.
Oh.
Which is something it's just funny because they have this massive entitlement that you will respond to them, right? So you are just a unsuspecting maintainer of a popular open source project, and you get a 40 question questionnaire sent to you by NASA, and they say, well, if you don't fill this, we can't use your software. And you think, what part of MIT license don't you understand, right?
Yeah.
It's like it's not fit for any particular purpose. But we, of course, because it's NASA, we did fill it out. I don't know exactly what mission this is planned to be used, but once we hear, we know. Obviously, because we're European, we don't have any telemetry in DuckDB, so we don't really know where it's running. But
explain that part for the audience a bit. Like, what do you mean by that?
Okay, so I think there is some cultural differences between the US and Europe. One of these differences regards the sort of sensitivity to privacy things. And I think it's pretty common for software projects, especially more modern ones that come out of the US, to have some sort of telemetry built in. Basically, they will phone home in some way and report, hey, I'm running on this IP, I'm this version of DuckDB, this is my Linux version, or this is my glibc version, like, I don't know. This is usually hidden from the users as an auto-updater feature or something like that, which is, or not hidden, maybe obfuscated is the right word here. But we are in Europe, and people care deeply about this sort of thing, and we don't want to leak any information, and we don't want to collect information that we don't strictly need. We don't strictly need to know where DuckDB is running, so we don't collect it. I mean, I mentioned earlier we do see the summary statistics on the extension installs, but that's just because they go through Cloudflare, and they will be able to report, like here, you had this many IPs from Germany and this many IPs from China, and so on and so forth. But it is something that we're conscious of. I think one of the strengths of DuckDB, being a local first kind of system, is also that you can have an app. Imagine you have an app like Strava, right? They had some privacy issues recently where people found out like where military bases were, where the like celebrities' houses are, how to best catch them in the forest. It's a bit scary. And it's why? Well, because the Strava app uploads all this stuff to the cloud, and then they use some big data BS to process it well. But there's not really a strong reason to do that. They could also just leave this data on your device, run DuckDB locally, do all these analytics, and then that would not be an issue. So I think that's something that is reasonable. It's not my main concern, but it's something that I think is nice if you can leave data under the control of the device that people have. I think that's a really cool thing about DuckDB, that you can just deploy it close to the user, and we have people running on phones. That's actually on iPhones. We did an experiment last week, a fun story. We found that in order to get the best database performance out of an iPhone, you have to put it into a box with dry ice.
Oh yeah,
because it slows itself down when it gets hot. So, but if you put it in dry ice, it doesn't do that. So
you showed me a picture of that too.
Yeah.
I think it was kind of melted around the CPU core on the upper.
It wasn't melted. The ice melted. Yeah,
ice melted. The phone wasn't melted. Just for clarity.
The phone died briefly after the experiment, but it thankfully came back to life after 10 minutes.
Was that your phone or somebody else's?
I have to admit that we bought it from Amazon and returned it.
Nice.
Sorry, whoever gets this phone.
You're a part of history. You just won't know it.
Hopefully we didn't break it too much. Yeah. But we wanted the latest model because obviously. And I want to, and Apple stopped making the iPhone Mini, so it's really Apple's
That's
fault.
one you have though, right?
Yeah, it's one I want, but they don't make it anymore.
Oh.
Yeah.
You're gonna have to get this like big bugger here then.
Anyways.
Yeah. Oh well. Well, it just means you have to have like bigger pockets.
That's true.
But yeah, I don't know. I don't want the Max though, because it feels like I'm having like a iPad Mini at that point.
Maybe good as a self-defense weapon though, right? Like if
you could do that.
You can whack people with it.
Yes.
Yeah, that seems like a nice.
That might be another test for you to do. Is like, at what force can I knock somebody out with my iPhone?
No, this is not. We are more about databases.
Okay. DuckDB could be collecting analytics. I'm not sure. Just kidding.
Oh yeah.
That's interesting. Like, so you gave a talk today. What was your talk about?
Today I talked about updating data, which is this one weird trick that I don't know that Hadoop doesn't know. I don't know, but this general idea that changing data is a good thing, and especially the transactional changes to data are a good thing, and that transactional changing to data are also a good idea for analytics, right? And it's actually kind of interesting because there are a bunch of popular analytics systems out there, I won't name names, that completely ignore transactional semantics, right? So you say you're loading a CSV file, the thing goes wrong halfway through, or something crashes, or I don't know, your internet goes down, and you wrote it. Yeah? Basically the file will be half loaded, and somehow that's acceptable. And so we have systems that I also won't name names, even though you're wearing their socks, that are not getting the durability right, where when you commit a transaction, the conventional, again, body of knowledge of database orthodoxy dictates that if you commit a transaction, you need to synchronize your disk changes to the disk using something called fsync. And there are systems out there that simply ignore this, because then they can say, but I get 15 million transactions per second and you don't, right? And this is true. If you disable syncing, you can do a lot. But that leads to the problem potentially that your database gets corrupted. It's not great. So I was trying to make this point to say, hey, we really want to have sort of classical transactionality for analytics pipelines. So that's, you start with, we want this, okay? And then you can say, okay, you can want everything, but is there an efficient implementation? And I think we've shown with DuckDB, because we wrote a bunch of blog posts on this, and we innovated what databases can do. We showed with DuckDB that you can actually have a full transactional ACID compliant transactional semantics in an analytical system without punishing performance. That's the big sort of asterisk, right? And I was trying to show also that if you have that, you can do cool things. Like you can, for example, do things like have all or nothing kind of semantics on reading a whole folder of CSV files. This is pretty cool to have, right? You can have all or nothing semantics on schema changes, on type change, schema changes, on table creation, table deletion, that kind of thing. It always will come from a consistent state and come to a consistent state. You can have constraints. I mentioned the art index that Pedro was working on earlier. You can have, say a primary key defined, and it's, by the way, it is, again, I won't name names, but it is completely common for analytical data management systems to ignore things like primary key constraints.
Yeah, it's common.
I know. And you know why it's common?
Why?
Well, it's because it's expensive, right?
Yeah.
It's like you need to check in a primary key. Is like, okay, you need to have some giant hash table or a B tree or God knows what to actually ensure that primary key is unique, right?
Yeah.
Or that constraint holds. And again, now we've worked very hard. One of our team, Tanya, she's our local index hero. She's been working very hard of making an indexing structure that will be able to check concrete constraints efficiently, at transaction commit, to make sure that your data goes from one consistent state to another consistent state, and that is really just something great to have. So that's kind of, I think that was what the main point I wanted to make, and maybe the sort of the one of the side notes that makes this possible is that we used to trade away everything in data for scale.
Yeah.
Like the entire NoSQL movement was essentially that, right? We said, hey, we need web scale, whatever that meant, back in 2001, lol, right? Before iPhones. We need web scale, therefore we need to throw everything overboard that we've ever had. Like again, we throw all the crap that these old database people had invented overboard for scale. And one of the things that I was talking today to Raise is like this. You probably have talked. Did you talk to Jordan, by the way, before? I think you have.
Jordan
right?
Degani?
Yeah?
Yeah.
And you talked about the big data to him, right?
Yeah.
Yeah. So you had talked about him. His makes a very good point about big data not being as big as maybe you think it is. And my point as a follow-up on that is like, yeah, okay, it's not that big, which means we don't have to trade everything away. We can have things like transactional semantics in a not terrible way. We can have basically data warehouse technology. It's a weird word. We'll have to talk about that.
Yeah.
In a non-punishing way from a performance perspective. But and I'd like to talk about Lakehouse formats very briefly because I don't like Lakehouse formats. Full disclosure.
Let's talk about that.
Full disclosure. So this is. How should I say? I think it's interesting because okay. I have to maybe as a bit of background. I really love file formats. Okay, I'm obsessed with file formats. I've personally implemented the Parquet reader in DuckDB. Of course, we worked as a team. We worked on our own file format. I've this week implemented the Avro reader.
You showed me the Avro code the other day.
Avro reader in DuckDB. We did actually do a paper about protocols. Lawrence, my current PhD student, he's doing papers on serialization, on data structures to disk. I really like file formats. I like, and I thought about this recently, and I think it's so cool because it's a dimensionality reduction. You have to somehow take a multi-dimensional structure. In a table, it's 2D, right? Columns, rows. And you have to put that into this one-dimensional thing, which is your file or your disk or your blob store or whatever. And that's something it's just somehow there's all the complexity inherent in it is really beautiful. So I spent a lot of time Parquet. And then when Iceberg first came out, I was like, okay, I know everything about Parquet there is to know because it turns out if you implement your own reader and writer, you learn everything there is to learn about Parquet in the process. So we did that, and so I thought, okay, I know this, I can understand Iceberg. And so I looked at it and I thought, okay, there's this JSON file on top, and then there's these Avro files on the bottom, 2 layers, because why not? And then underneath there sits the Parquet files with the actual data. And it seemed extremely cumbersome, and I couldn't really, I could, at the time, I could only really criticize the choice of Avro, which to this day I don't understand why you have 2 different metadata formats in one system. But it's actually I think my beef with Lakehouse formats is actually something else. It's more this, this idea of bringing basically core data warehouse features back, but in a really bad way. It's hard to explain. It's in a sort of in the worst way, right? For reasons of like you're making technical decisions based on sort of market force reasons and not really on technical reasons. So I think the reason people got fed up with data warehouse systems in general is because of pricing model, right? I would argue.
Piece, yeah.
Is that fair to say? Like if Oracle hadn't charged per CPU, but instead, I don't know, something else, would like NoSQL ever have happened?
Are you talking about for the big tech companies that came up with their own solutions, like the Hadoop and the other stuff?
If Oracle hadn't charged, hadn't you? I mean, okay, I don't want to hit only on Oracle, but if sort of big database in the late 90s hadn't had these pricing models that were essentially they still have, that were, let's say, assuming your data has a high value per byte. I think that's fair to say, right?
Right.
If they had maybe had some other model, then I think a lot of the NoSQL movement would not have happened, because people would have installed, happily installed, I don't know, SQL Server.
Yeah, or like Postgres or something like that.
Postgres was free, right?
Yeah.
And Postgres was not where it
is now,
right?
Not.
So, but I think a lot of this has to do with market forces. And so people ended up hating data warehouse technology. And there's, of course, other vendors that are more on the analytics sides, but I think the same restrictions apply. You had to have very deep pockets to again, golf course technology. It
was expensive back then.
Yeah, exactly. And so I get that. But then people made, again, technical decisions like, let's throw all this stuff overboard, because the market sort of incumbents weren't willing to compromise on their pricing, I guess.
I think it was a big factor of it. I'd love to talk to some of the friends who were at the big tech companies at the time. Because I think it was that, plus there was a sense of just not scaling to, quote, web scale, which is an entirely different discussion, obviously.
Yeah.
But yeah, I think the notion of just let's throw things on commodity servers and figure out how we're going to work with that was a big driving force for sure. But at the time too, and for people who listening, it's like the vendors for these database companies, database.co. I mean, they big database, I suppose. It's aggressive, right?
Yeah.
I mean, and I know like some of these companies, if you decided to break the contract, also penalties for that. So, there's a lot going in and a lot going out. Yeah, it's true. Yeah,
I get that. But now what we're seeing market forces being, I mean, we see the incumbents, I would say cloud data warehouse vendors. Mm-hmm. There's 3, so I don't have to name them. And those, again, people whining about, I don't know, complaining about the pricing model, I don't really know about that. But so now and then that happened, and we got data lake, right? So people essentially said, fine, we'll just dump everything into S3.
You're talking about the original data lakes, like the HDFS ones?
We'll put everything in as HDFS. Yeah, exactly.
Yeah.
So we'll not give money to these evil people. We'll put everything in, what is it called? Sequence files? Yeah. Remember those? What a horrible thing. We put everything in sequence files on our HDFS, and we'll run some Java concoction on top of it. And that's going to be better than paying vendor X. And that went on for 10 years or so, I think, right? And we got Parquet files, better, right? But now we see the swing back, right? Now the swing back is happening. People want to clearly need data warehouse features, like or want them or demand them or something like that.
I remember the conversations back in the 2010s during the quote big data era.
Yeah.
Was that data warehousing and BI were going to go away. Data warehousing was dead, especially when Spark came out. That I think there was a lot of chatter that the days of data warehousing are done. You fast forward to today, and it's interesting because Spark, Databricks, it's SQL. It's basically the Lakehouse. My friend Bill Inman, who came up with the data warehouse, actually wrote a book on data lakehouses about it. So it is interesting. The pendulum swings back and forth. I do recall the conversation was SQL's dead, data warehousing is also dead. You need to forget about this stuff because we're moving in. This is also around the time of data science, though. So I felt like there was a lot of, in retrospect, hubris about the power of using data frames and all this stuff. And because it felt like the data frame was really going to supplant everything. There was a point in time when Pandas was roaring ahead, and then Spark comes out with distributed. It was the RDD at first, and then distributed data frames. But it felt like that had a chance of being the paradigm for like a split second, and then it wasn't. Yeah, that's absolutely true. And I think it's interesting because I see parallels there to what we saw with NoSQL for transactional use cases. Absolutely.
Because people were saying, key value is all you need. let the eventual consistency is all you need. Let the application developer figure it out. Well, it ended up the application. Well, your socks, yeah. It ended up what ended up happening is that the application developers were not happy dealing with eventual consistency, and in fact couldn't deal with it. Same happened with query languages. People said, we don't need query languages. We'll have the application developer deal with this. Have a joined application. Well, turns out that wasn't a great idea either. And I think we are starting to see the same in analytics now, where the data lake and data science movement there basically put all responsibility on the individual data scientist to say, you get to dig into this sort of giant data lake, find the things that are relevant to you, decode them, read them, parse them, put them into a data something, and now the same effect is happening where they say, no, well, some of these data warehouse features are actually great, like being able to make a change to a table. That sounds like great. I mean, you can do it a bit if you have a zoo of like a folder of Parquet files. You can throw another Parquet file in there. Great, that works. But it doesn't work if you want to, I don't know, add a column, right? Doesn't work well. It doesn't work well if you want to remove rows. Now you have to basically invent your homegrown sort of invalidation system, homebrew invalidation system for it. So then we're seeing Lakehouse formats, which are essentially doing that. And I think what we're also seeing is these catalog things, right? And together, if you took the user's credentials for S3 away, then a catalog and Lakehouse formats are exactly the same as the old school data warehouse, right? Like, okay, the only difference that we have left over is that maybe you can have those, maybe you get to poke around in the files yourself. And then the question is, do you actually want that? Is this a good idea?
Right.
I would argue that there are political reasons why you want to do this. You want to be able to blackmail or pressure your database vendor. You want to threaten vendor X that you're going to leave them for vendor Y because they're both using the same formats. Okay, sure, I get that. That's a political reason. Again, not a technical reason.
Right.
And there's also just some extreme serious limitations on Lakehouse formats, right? Like, I don't think anybody can realistically show me a path to more than one transaction per second on an iceberg file. Like, I just don't see how, right? You have to stage all your Parquet files. You have to write the metadata files. You have to write the new root sort of metadata thing, and then you have to do a commit in the catalog. I think that's the way they think about it, to actually switch. Like, that's okay. One transaction per second. That's like 1960s style, right? That's not, and even then they could do more than one per second. By the way, I recently learned a fun fact. Did you know that the booking code on your flight tickets used to be a pointer? So that was the actual pointer to the record.
Oh, really?
Yeah, and so they basically they had tapes with all the bookings for flights, and that record locator, which is why it's called a record locator, was just a pointer. And with that pointer, they could find your record by just going to that point on the tape. Anyways,
it's interesting. Bill Inman actually told me that on a similar note, the plane ticket, the paper ones used to be a punch card.
Yeah.
So these probably are related somehow.
I don't know that. But to come back to the Lakehouse format, so we're essentially building these things that are inferior to the state of the art from 20 years ago. Somehow get excited about it, and what I think is going to happen is that somebody is going to, like what happened with Hadoop, basically, and the MapReduce paper, is that somebody is going to build a clone of a cloud disaggregated storage cloud data warehouse that works. And I think once that happens, we're probably going to forget about data lake formats quite quickly, because then you have the entire sort of feature set in one place again. You have catalog, you have query engine, you have storage, you have updates, you have authorization. Authorization is something that there is no story in Lakehouse formats and how to do that, right? If somebody has an S3 key for your files, it's over. And this is actually one of the things where we're getting a lot of requests at the moment. It's like, is there any way you crazy people at DuckDB can make row-level authentication possible for Lakehouse formats? And I'm like, I have to tell them, like, there is just no way. You give somebody an S3 key, it's over, right? They are there. They can do anything, which again, it's very interesting from a sort of democratization of access perspective, because I think one of the things that made data science in its heyday so successful is because we had a data lake, and there was just the Wild West of Parquet files, and essentially there was no governance, right, of any sorts, and your low-level analysts could just go and grab some Parquet files, and that's, I think, another swing back that we're seeing, that actually we have tons of regulation we have to follow now. We can't just do that anymore. We need to give, we need to do proper authorization and logging and all that stuff. And lo and behold, we're back at sort of the full-scale data warehouse. So I don't know. And one of the things that actually I'm a bit concerned about in that space is like DuckDB. One of the, I think, reasons why DuckDB is popular is because there is the Wild West, right? You can just download a Parquet file from your S3 or point directly to it right now, and your IT department can't really stop you from doing that.
Right.
But if the pendulum swings back further, and this is kind of what we're seeing now with these catalogs, where you do need credentials and they hand out, they deal with all that stuff, it might not be so easy in the future. And so this is actually, for us, it's a potential threat that the Wild West disappears more, even more. That we would just lose access to this stuff, because in the end, if you need to pay Snowflake anyway, I'm sorry, I mentioned a vendor, a cloud. If you have to pay a cloud data warehouse anyway to get access to your data, then there's no point for you to using things like DuckDB or things like, Polars or things like ClickHouse, or it really doesn't matter. Like one of these more like, let's say, guerrilla data tools, because you're paying them anyway. You might as well use their stupid compute, right? I mean, valuable compute. It is interesting to see. I'm really curious what will happen there. I think we'll see that that sort of clone, like the Hadoop of cloud data warehouse appear. Hopefully not in Java though. I don't know.
It's all coming back.
It's all coming back. We're gonna have distributed real-time Java again. Yes. Anyways,
you mentioned local first.
Yeah.
That's an interesting movement right now. I know Martin Kleppman. He's working on some really cool stuff with decentralized protocols. Do you envision like a decentralized version of DuckDB?
It's interesting. We did we do have a current research project running on this. Actually, I did get a grant for a research project with responsible decentralized data architectures, I think is the term, is the name. That is imagining this idea of there's going to be a fleet of DuckDBs running. They're going to be under users' control, but we're still the idea is that you can still, for example, run aggregations over the whole fleet of systems with partial results being shipped back up. That's interesting. I haven't seen the research project is mainly there because you need to build some abstractions for this to be something that is not just a one-off that somebody hacks, because you can totally build that today, right? Like nothing keeps you from building that today. You can ship intermediates around. There are some organizations that have built pretty wild things around Parquet files that are being sent around, or arrow buffers or anything like that. But I think we need some abstractions there to make this like nice and efficient. I think that MotherDuck is doing some interesting stuff. So for those who don't know, MotherDuck is a company that's building a DuckDB as a service, and their execution model is this whole hybrid execution where you have a DuckDB local, you have a DuckDB on the server, they talk to each other, the query gets split up and run partially there or there, depending on where it makes more sense, depending on optimization. And I think that's super interesting. I didn't actually see that one coming. I thought, okay, they're just going to do DuckDB as a service, done. But no, they actually have been innovating in that space as well, which I think is really cool.
Yeah, I remember when Jordan first mentioned, and this is around, I think it's right before MotherDuck was announced, and I was just kicking myself because I asked, can I put some money in that? Sounds awesome. And he's like, we're oversubscribed. I was like, damn it.
Yeah, well, thank you for the trust. So, I think it's really exciting to see what at the moment. I think our from DuckDB Labs, from DuckDB the project perspective, we are very much sort of focused on a single node.
Yeah.
Because that's sort of the space we inhabit, right? That's like we do the best damn job we can do on that in that single node environment, and then I think it's up to other people to build sort of crazy combinations of this.
Sure.
We don't have the resources on or the team really to do a lot. We have a small team. We are 20 people. Wonderful team of database hackers, but we can only really with that size of team, right? We can only really focus on one thing, and it's gonna be like single node execution.
And what's your philosophy though in terms of, is a pendulum swinging back to single node? Are you saying, or what's
I think
the trajectory?
That's an excellent question. I think that the distributed things. I think that there's a wonderful talk at ICD. It's an academic database conference. I think it's data engineering even international. You should go and speak.
I should go and speak.
Where he basically says that database researchers have been solving the whales problems for the last 20 years. Basically solving the problems that Google has, that solving the problems that Google, what else? Anyways.
Netflix, the big ones, right?
Yahoo,
the ones with the blogs.
The ones with the blogs?
The ones, the big tech blogs.
Yeah.
But here's the problem. So what I always see in this is, the big tech companies will publish the blogs. Here's what we're doing. Iceberg, for example, right? Built at Netflix because it solved a Netflix-like problem. And they build a lot of stuff there. If you're a smaller company, like say DuckDB is I don't know, you suddenly sell furniture or something like that. You just big pivot, or ducks, whatever.
Boats.
Very abstract.
Yeah.
Boats. Okay, so then you have your data warehouse, right? Does it make any sense for you to do something, like that, or do you? So
it does not make sense.
Yeah, but so when I say the blogs, that's what I mean. Everyone looks at the blogs like, we got to do that at our company too, right?
Yeah.
So.
No, this is exactly right. There was this one thing where Uber wrote about how they ditched Postgres for MySQL.
Yeah.
Remember, or the other way?
I think it was the other.
I don't remember.
Which? Yeah.
Who cares? The point is, it made huge splashes in the data engineering community, and it didn't matter for everyone. Like it didn't. Like it matters to Uber, sure, right? But I think this point about people solving the whales problems is really interesting because we have been neglecting sort of the 99% of people's data problems, because we cannot tell like your boat boat sales company to go install Spark. Like there's no point ever for them to run Spark to deal with their customer data. Yet we have been telling them that for the last 10 years, right? Oh, you want to do data stuff? Go install Spark. Like that's not a great.
Well, otherwise you're not a real data company.
Yeah,
sure. I'm saying that jokingly, but it's
yeah. But I think this is also where we see our role, especially since we started as taxpayer-funded research as a taxpayer-funded research project. Is like we need to solve the real data problems out there, the problem of the 99%, which is the people that run out of steam with Excel, right? It does not make sense to solve Google's problem. They have clever people. They can afford to pay the clever people. The clever people, are capable of building a solution that works for Google and no one else, and I don't care.
Yeah.
It's like it's a different ball game, I think. And I think it's super interesting if you look at these studies that came out from Redshift and from who else? Redshift and the other one.
Snowflake had a private one, but I think they didn't release the full benchmarks. I'm not. Yeah, I know Redshift.
The Redshift one is well known. To see what data sizes actually look like in the real world, and Jordan has been talking about this as well. What he saw inside BigQuery, and these are all data sizes that are completely manageable. You could argue about the point whether you need disaggregated storage or not. Right, that's an interesting point. Jordan says yes. I say probably not. But because you're writing 10 years of data, maybe you want to have disaggregated storage so you don't run out of disk space. But again, disks are gigantic. You can get a 20 terabyte SSD, no problem. It's pretty wild. So I think that fundamentally, our tech is is getting better, faster, at a quicker rate than our data sets are getting bigger and more challenging, and therefore we're gonna see actually much more of the sort of single user workload, no problem, moving to single node. And your laptop, you have your laptop. Hey, let's make it work.
Well, the laptops are insane these days.
Insane. You have 6 gigabytes per second I/O speed on a MacBook.
It's
right?
nuts.
Like that's. I don't know what to. I don't even know. And we managed to, maybe managed to get that busy with DuckDB. That's not the point. But it's unheard of.
So one thing you were talking about, when we were having lunch, so I think somebody asked about memory versus DuckDB. Maybe can you walk people through sort of how to think about that?
Yeah. People think there's a misconception that people think that DuckDB is an in-memory database. It is not. It's not an in-memory database. We can use memory. We like memory. It's nice. It's fast. But we're not limited by it. So again, with Laurens, my PhD student, he's been working on the DuckDB larger than memory capabilities. So we've always had this thing that your input data could be bigger than memory because we read it in a sort of a streaming way. Like if you point DuckDB to a Parquet file, it will not first copy that Parquet file into RAM and then do things with it. That would be dumb. Instead, it says, okay, we'll start in the first row group, second row group, and so on and so forth. However, there's operators in relational sort of analysis, like so-called blocking operators, like join, sort, aggregate, some window functions, top n, that may have to materialize actually a large amount of the input in itself. So if you're loading a terabyte of data, we might read this in a streaming fashion, but if you aggregate on the unique key, we will have to put it into our hash table for the aggregation. This just the semantics of SQL dictate this. And it's pretty common in analytical systems to actually fail or do something very slow in this case. We have some papers that show that, but in DuckDB we actually built something that's called graceful degradation when we reach the memory limit, which means that we start using the disk. And that's only really possible because we have these crazy SSDs now, because we can actually offload to disk at 6 gigabytes per second and we can read it back at 6 gigabytes per second. And we don't get slowed down by multiple threads doing the same thing too much. So it's improved quite a lot compared to the spinning Rust kind of thing, right? And then, so we can essentially, for things like aggregations, we can offload part of the intermediate result to disk and then basically resume. And you will actually not feel a performance cliff there because it will just, it will still use as much memory as you allow us to use, but it will just also be able to use the disk. This gets even more interesting if you have a join, because you can have multiple joins in the same sort of query, right? And then now we have multiple operators running at the same time, fighting for memory at the same time. And now you have to think about essentially a fair allocation strategy between those operators. And again, we have a paper that Laurens wrote that's currently under revision at VLDB, which is a large database conference, that describes how we've implemented the strategy to deal with this in DuckDB. And the result is that you can set a fairly low memory limit in DuckDB, run complex queries that everybody else essentially blows up on a single node again with your disk, and still finish those queries in a reasonable time. We call it the Galaxy Quest principle. Have you seen Galaxy Quest?
No.
It's this movie, this like lampooning Star Trek. It's very funny. It's with Tim Burton and Sigourney Weaver, I think. And in Galaxy Quest, it's this fake TV show that's like Star Trek. And they have this catchphrase, which is never give up, never surrender, right? And so we took this Galaxy Quest principle to the query processing, which means that we just never want to give up, we never want to surrender. We'll always be able to finish the query provided there is enough disk space to do it. We cannot control what users are doing. If you cross-product a giant Parquet file, it will be the end. We will abort probably, but if it's in any way reasonable, we want to finish. And I think that's something that is unheard of in research systems. It's also pretty unheard of in other database systems. Like if you have a cloud data warehouse, if you have distributed query processing, you have to do these shuffles. There are just going to be no-win scenarios where a whole partition has to fit on one worker, and if it doesn't, it's just game over. Like Spark has this problem a lot. But I think on single node we can do pretty cool things there and make sure that we finish.
That's interesting. How does ACID work in that environment where?
In which environment?
Well, in the situation where you have a small amount of memory.
Yeah.
How do you make sure that the transactions are committed or rolled back?
Right. So this is independent of query processing, right? So when a query starts running, we'll run it. MVCC, the multi-version concurrency control, will read a specific version of the table.
Okay.
Right? And that's going to be consistent during the runtime of the query. So we'll read this specific version. So that has nothing to do with memory. It's just we run this version. What is more interesting is how do we deal with changes that are made within a transaction that are bigger than RAM, right?
That's kind of where I was getting to, is that question.
Exactly.
Yeah.
And that we're also able to offload this. So the write-ahead log, that where basically changes go in transaction commit, that will of course be written at the end of the transaction, but we do speculatively write big changes already to the database file. Okay, so we're running this is because we had this actual problem. Let's say you have a table, you're inserting a terabyte CSV file in a transaction, and then you're committing. Okay, traditionally what would happen is you're writing that terabyte file in your write-ahead log because you need to be transactionally safe. Then at checkpoint, you read it again, and you actually write it to your persistent table, at which point you truncate your write-ahead log. Now you've basically written this terabyte file twice to disk and read it twice, because you read it once to read it in, and then you wrote it to the val, and then you read it from the val again, and you wrote it to the main persistent database. That's not great, right? That's both read and write amplification. So in DuckDB, what Mark has built is speculative writing of large changes. So we will already write in the database file, but only at transaction and at commit into the val, we only write references to those blocks, and only at checkpoint we will essentially mark these blocks as being used. So in the main sort of header. So that means that basically in the default case where it works out, we will write it once to the database file, and that's it, and we're done. And then some metadata has to be updated later on. And in the failware, in the case where we abort, we'll have written some blocks to the database file that we then mark as empty. So nothing. So the worst thing that happened is that we made our file a terabyte bigger. But that's something that we will be reused. This space will be able to reuse later on. So we have thought about this, and this is exactly what I meant. Like we've thought really, how do we bring these transactional semantics to analytical use cases without making it slow, right?
Yeah.
Because you assume that this is going to work out well, so the default case is going to be fast. The worst case when it aborts is going to be we used some disk space. Oh no, it's a good trade-off, I think, from our perspective, right?
Yeah.
So these are sort of things that we do in DuckDB to make this work.
That's interesting.
Yeah, it's a fun thing to do. It's nobody has been there before. It's
right.
It's really like nobody has tried to write a terabyte to a val. Like that's or not to write a terabyte to the val. It's really funny how the other guys do this. So most systems out there, again, not going to name names, have a sort of bypass of the transactional sort of system for bulk loads. So you have a special tool. Then you're basically bypassing the whole transactionality just for bulk loads because that doesn't work. And then, that's of course not what you want. For us, reading a big file is a common operation, so it needs to be transactional.
Are you saying like a copy command?
Yeah, it is like a copy command, but then there's this, usually there's a separate command line tool that this just bypasses the transactional log. Yeah, it's not great. But because if that goes wrong, then you're back to not the things that's not to be done. Anyways, it's a fun thing.
Are you seeing any streaming use cases with DuckDB?
Well, we're not a streaming system in that sense, so maybe by definition we don't see a lot of demand for it. I think there's really amazing streaming systems out there like Materialize. I don't know if you've talked to them already.
Yeah, I know Materialize. Yeah, Arjun, those guys. Yeah.
So I think they have really amazing tech, and it would be really weird for us to try to make a knockoff. Like there's another unnamed database company or self-declared database company that's taking their bulk system and slapping on some sort of lightweight fake stream thing. Shouldn't be. We don't want to do that, right? Like that's just embarrassing. So I think the real way how to do streaming is like what Materialize is doing. Like they have Frank's magic that makes this really work. So I don't think we're gonna go there in the near future. What we might end up doing though is maybe that we have materialized views that can incrementally update, but that's not really streaming, right? That's more like it's more updated materialized views. I think streaming itself. If you use the ones we have users that use DuckDB for streaming use cases where they just they do an insert and they do a delete at the same time, and then you have and they rerun the query. That works. It's not gonna work well. It's really not.
It seems kind of expensive.
I think it's also what the unnamed vendor is doing. So it's like, yeah, man. You see if you're long enough in data engines, you see things, right?
I'm sure.
Oh my God, it's like this fsync thing. It's really amazing. Like I have to say. So in my class at some point years ago, I had a student saying, but the key value store with the socks manages like.
So the socks he's referring to, it starts with an M, and it's a database company. I'll let you figure out the rest.
I don't know if I'm allowed to say it or not. But there was this thing where somebody said, yeah, but this system can do 1 million transactions. I forgot the actual numbers. 1 million transactions per second, and Postgres, being old and stupid, can only do 100,000 transactions per second.
That's what they're saying.
That was the blog post with the benchmark and everything. And so I looked at this and thought, bullshit. And I looked at it, and in the lecture, in the next lecture, I brought my laptop, and I was like, right, I figured it out. We'll run an experiment right here, right now. I'll show you once and for all. Because it turns out if you enable the proper logging in the key value store that was bragging about performance, lo and behold, it went to 100,000 transactions per second. Yeah. And Postgres has a flag to disable them. And if you do that, lo and behold, it went to 1 million transactions per second. So the braggy result from the blog post turned around 100%. And if you had actually configured this fairly, either both of them do it or none of them do it, it would have, they would have been the exact same result.
Interesting.
And I think it's so funny how defaults sometimes matter. Like, again, with the example I mentioned with the, today with the routers bricking themselves because, again, the same system wasn't using fsync. They probably wanted to have this, but the default was it was off. So they erred on the wrong side, if you want. Right? Postgres will always err on the side of caution, and I think it's the correct thing. If you want to optimize the hell out of it, then you can by setting the flags. It's just that you need to actually look at it and not just write a blog post.
Yeah, somebody wrote on Blue Sky today about, I can't remember who it was, but how not to do database benchmarking 101. And I guess it was just about certain metrics of performance, but didn't take into account indexes and rebalancing there.
That's a classic, yeah. We wrote a paper about this.
What's that?
We actually wrote a paper about this.
Oh?
Yeah, it's one of our most cited papers. It's database benchmarking. I forgot the actual title of it. It is meant as a how-to, but we actually, if you're curious, there's a paper on this that
go check it out
from us that lists the most common benchmarking crimes.
Oh,
yeah, which is but. Absolutely, like pre-processing time is definitely one of them. It's an easy way of winning a benchmark is to pre-process the hell out of it, and then depending on the benchmarks, also like there is also a lot of lawyering going on. You know TPCH, right? You've heard of it, right? It's terrible. It's pretty old and busted. People should be switching to TPCDS, much better benchmark. But even that, there's real benchmark lawyers out there, right? That look through the spec and find like the thing they forgot, and they will exploit that thing, and then they will win at the benchmark. It's kind of weird.
Well, that's funny. And then some databases don't let you benchmark because of the do-it clause.
The do-it clause, yeah. Like I think that's the famous one. So then you see DBMS X and DBMS Y and all that stuff in papers, which I don't think is helping science a whole lot. But
what's that?
I mean, because of the DeWitt clause.
Oh, okay.
People can't say I ran this on Oracle because people fear Oracle's, legal department, probably for a reason.
Yeah.
And then instead of saying we ran the result with Oracle was this, they will say the result with DBMSX was this, and then it's up to the reader to guess what that was. I don't know. I don't understand that, but then leave them out. Who cares?
Yeah.
But benchmarking is an interesting thing. So because it's so hard to make fair benchmarks, we actually don't publish any benchmarks of DuckDB against something else on like our website. So we don't have anything there. We call this a home game. Obviously, it's much more interesting to win an away game.
Yeah.
So and that's when somebody else runs the benchmark. So that's the ones that I think are more interesting to us because they hadn't. They probably haven't spent a whole lot of time optimizing, which is, hard to not to do if it's your system.
Mm-hmm.
So we're not doing anything of that because, it's also like raw performance is overrated. I think we talked about this earlier about the ease of use. It's not that DuckDB is not fast. I think it's a very competitive query engine, but it's not the end. It's not the end all of data things. You need to solve a problem. You're not solving the problem by being 2% faster and then the user not being to install it because you're using some Intel intrinsic that you don't have.
Yeah.
So it's probably worth more to not have the 2% extra performance, but knowing that this will run on every Intel processor made in the last 20 years. Just saying.
That's interesting. How did you guys become so cool?
I don't know. I'm not cool. I think I'm database cool.
Database cool, but
that database cool is something very different, right? Cool. I will never achieve cool. I know this.
But you're not like Taylor Swift.
Exactly.
But you're kind of the Taylor Swift of the database world.
Right. But I have to admit the bar is much, much, much lower, right? I really like databases.
Well, it's you and a bunch of neckbeards.
That's right. And I have shaved today, so I'm clearly not one of them. But no, I know this is like the people obsessed about tables and query engines is a strange subgroup of people. I will admit we managed to be cool in that subgroup of people.
Yeah.
And that's okay. That's all we can really ever hope for. It's not going to be coolness as defined by others. Whatever.
And what do you think it was, though? Because I mean, it's you enter the database field. It tends to be pretty dry. Tends to be pretty, whatever you want to call it, right? But you guys have a cult following.
We have. I can maybe say what originally drew me to the field was the low amount of bullshit that I initially perceived. So in data systems or in systems research in general, there is a definition of right and wrong. Of course, after 25 years in the field, I have learned that it's not that clear cut. But at least there was a definition. And when I was at university, where people doing things like human-computer interaction with or visualization or like things that are quite hard to actually evaluate in a scientific way. Right? You have to run like a user study. You're asking 200 people what they think, which plot they find prettier. It's not very hard science. It is science, of course. I don't want to disparage this, but it's not something that I want to do. I like this idea of there's being there's a test, you run the test, you see who's better, at least on this specific test, under these specific circumstances. So I think that, that's what I really liked about databases. Why the cult following? I think making the user experience great is something that has not occurred to anyone in databases yet. I think we may be the first people to actually care about user experience. And it's not entirely fair because there's other vendors but certainly like open source systems, I don't know, there's not a lot there. There's people in the NoSQL world that have gotten it right, which is where we took some inspiration from. There's SQLite who got it right?
Yeah.
They are the world's most widely used database system for a reason, while being still extremely weird in other senses. But I think that if there is a cult following, I'm happy to hear it, but then I think it is because we really put the user first and not our orthodoxy. This needs to be nice this needs to be easy to use, needs to be nice to use, it needs to make you solve a problem and not satisfy our academic curiosity or our need to be the fastest. Because in the end, right, like let's say we win on a benchmark. Say we run this big, huge benchmark, we spend a year optimizing for it, and we go out with big fanfare, like other database vendors have recently, and say we beat TPCDS scale factor so-and-so, and screw these others who are slower. Is that gonna make the life of a single one of our users better? I don't think so. If we spend the same amount of time on like the CSV reader, is that gonna make the life of our users better? Absolutely. So it's clear where we have to go, right? We're not gonna run a giant benchmarking campaign. It just makes sense. Yeah. And I would hope that's why people like DuckDB. Not us, DuckDB.
Closing out, like, what are you excited about over the next year or two?
Yeah, I really like this extension ecosystem that we started building.
Yeah.
So for those who don't know, we basically made a pip for DuckDB that's kind of built into the system. You can just install extensions that can add features, like they can add new file formats, they can add new functions, soon it's going to be able to add new syntax. And I think that's really where I think the project needs to go, is become this runtime fabric, host for the Cambrian explosion of creativity from people that are in that care about one specific subset of it. Like we have people in geospatial that are doing cool things there. Yeah. There's people in like compatibility with other systems that are doing cool things there. There's people doing file formats, all sorts of crazy things. Somebody I think made an XML reader. Great, right? Like that the world has XML files in it.
Pendulum will swing back at some point.
Oh god! You missed it. So that's I think what I'm really excited about. Obviously, to see where this can go, and I think enabling people, building infrastructure is always going to be the winning sort of thing to do. And if that has nothing to do with like any sort of commercial interests, it's just that we really care about what is the state of the world in terms of how people look at data, and I want people to just be comfortable with like wrangling data and not be like terrified of it. So
it's awesome.
Yeah.
Thanks, man. It's good to chat with you finally, and good to finally meet. I know that we've been in each other's orbit for a bit, and
Thanks so much, Joe, for the nice chat, and in Paris.
Awesome. All right. Well, au revoir, or auf Wiedersehen.
Au revoir.
All right.